కనిపిస్తుంటాయి. మీరు నీట్గా చూసుకోండి. ఏమన్నా నేను ఎక్కడైతే ఇంపార్టెంట్ అని చెప్తానో ఆ పాయింట్లు రాసుకోవడానికి ట్రై చేయండి. సబ్జెక్ట్ పేరు, బుక్ నేము అన్నీ. సరే అమ్మా, ఐఎమ్ స్టార్టింగ్ నౌ. సో subject name is electrical power transmission system. So and code is 15A02502. So, after completion of this subject, the students will learn the following matters. That is nothing but how to calculate the transmission line parameters for single phase and three phase. That is nothing but single phase and three phase as well as three phase. You have to calculate the resistance value, inductance value, capacitance value in a transmission line. So what is the value of L, what is the value of C, clearly calculated for the single phase and three phase. And next one is, so how many insulators will be connected to the transmission line for overhead system and underground cables, and what are the design of transmission lines. So there is nothing but sag, tension, all these things you have to learn after the completion of the subject. And also we can design the short, medium and long transmission lines. How can you say that? So this transmission line is a short transmission line or long transmission line or medium transmission line. Under that one, what are the types? Pi type or T network or pi network, or distributed parameters or lumped parameters, like that. You have to know all about transmission lines. And also construction of underground cables. Cities like Bombay, Calcutta, Hyderabad, Chennai. So heavy density people will be living in that city because of we have to utilize underground cables compared to the overhead system. So what are the types of cables and what are the improvement of cables? There is nothing but grading of cables. And performance, there is nothing but testing different types of cables, single phase, three phase, three core cable, like that. You have to already. So first, so you have to complete, after completion of this subject, you people aware the where transmission line utilized and what are the advantages of transmission lines, transmission system, and what are the problems in transmission system, and also how to design the transmission system. These are all how to learn now. Coming to the first unit, transmission line parameters. Type of conductors. That is nothing but transmission line. What is transmission line? It is a conductor between the remote generating station and to the load centers. That is nothing but it is a carrier. It carries the power from generating station to transmission system. The transmission system means near the city. In transmission system, primary transmission system is available and secondary transmission system also available. So totally transmission system is a conductor or a carrier between the remote generating stations and load center. What is the need or what is the necessity to construct a transmission line is nothing but supplying the electrical power to the consumers. So we have to generate the power at in a faraway distance to the consumers. So we are the people living at the KAVALI city, but generating station is our nearest generating station. It may be a thermal. You can take Vijayawada thermal power station, VTPS. Suppose go to the idle, it is a Srisailam. So from that place to our place, the power will be transmitting. So that is the main necessity, supplying the electrical power to the consumer within the specified limits of frequency. Generally in frequency, our India 50 Hz, but some limitation will be there, that is 49 Hz to 51 Hz. There is no problem. So under that specified frequency, you have to transfer the power from generating station to consumer premises. So for that type of conductor is nothing but carrier to carry the power. So type of conductor is nothing but ACSR conductor, bundle conductors, standard conductors, like that conductors will be available. Mainly we are using ACSR conductors, right? So after go to the class, I will clearly explain the ACSR conductors. Another one, resistance for solid conductors. The transmission line will consist of resistance, inductance, capacitance, conductance, R, L, C, G parameters. Transmission line consists of 4 parameters, but because of some limitations or some assumptions, we ignore the resistance and conductance. That's why in transmission line we have to calculate only inductance and capacitance. That's why, so what is the calculation of inductance for single phase and 3 phase, and also calculation of capacitance for single phase, 3 phase, symmetrical network, asymmetrical network, and also concept of GMR and GMD. To calculate the inductance or capacitance, so concept of GMR, GMD is the basic one, more important one. For gate exams, so concept of GMR, GMD is more important. Another one is some effects will be there. Skin effect, Progeny effect. What is meant by skin effect? That is nothing but, so tendency of current concentrate near the surface of the conductor. Generally, the current will be concentrate surface of the conductor, not center of the conductor. That effect is called skin effect. You can explain clearly. So whenever we are going to that concept. So these are the first unit. Calculation of L, calculation of C for single phase, for 3 phase, and symmetrical and unsymmetrical, and also effect of earth. And GMR, concept of GMR, GMD, type of conductor, skin effect. So in this unit, we have some problems and mainly derivations. Derivations is there nothing but calculate the inductance for single phase or 3 phase, symmetrical or unsymmetrical, 3 derivations. Similar manner, calculation of capacitance single phase, 3 phase, symmetrical, asymmetrical, 3 derivations. And also effect of earth, that is only applicable for capacitance, that is another derivation. So for capacitance 4 derivations, for inductance 3 derivations. So out of these 7 derivations, compulsory 1 derivation is coming to the examination. And problem, and connect with the problem, right? So this is the transmission line parameters. Next, performance of transmission line. That is nothing but you have to calculate the classic types of transmission line: short transmission line, medium transmission line, long transmission line. Suppose, so from Vijayawada to Guntur, the distance is very, very less, and Vijayawada to Ongole distance is somewhat greater than the Guntur. Coming to the Nellore, so distance is more. So like that, so depending upon the distance, you have to classify the transmission lines: short, medium, long lines. Basically, transmission lines are classified based on voltage, generally voltage. So 100% category based on voltage, but we go for the distance in subjects, in textbooks, go for the distance for less than 80 kilometers. So 80 to 200 or 80 to 100, 300, greater than 300, like that, depending upon the distance. So transmission lines will be classified. and their equivalent circuit for short transmission line. How can you calculate the voltage regulation, and also sending end voltage, receiving end voltage, power factor, like that. Similarly, medium transmission line. In medium transmission line, nominal pi, nominal t, and also calculation of regulation and efficiency, and also long transmission lines. These are also nominal t, nominal pi, and also calculation of ABCD parameters, ABCD constants. So already we discussed about the ABCD parameters in two-port network in electrical circuits. So that parameters will be calculated in transmission lines, medium and long transmission lines. And these are the problematic and theory. Now go for the theory. Surge impedance. What is surge impedance? What is the surge impedance loading? So wavelengths and velocity propagation. So Ferranti effect. Some numerical problems. This is the second unit. Now third unit is mechanical design of transmission line. That is nothing but overhead line insulators, concept of corona, sag and tension calculation. So type of insulators, how many depending upon the voltage rating, how many insulators are connected to the transmission line, or 6 or 12, like that, depending upon the voltage rating. So number of insulators will be connected to the transmission line, and their efficiencies. There is nothing but string efficiency. How string efficiency will describe the voltage gradient between
సార్ వాయిస్ వినిపించట్లేదు సార్.
ఓకే ఇప్పుడమ్మా
ఓకే సార్.
ఓకే. So concept of corona is nothing but, so in transmission lines all are appearing in the atmosphere itself. That's why so many problems will be occurring. So because of ionization property, the transmission lines will lose its property such that corona will appear. So whenever corona occurs, so ionize, that means ozone gas will be producing, and bluish light will appearing in the transmission lines, and also some some smell is also occurring surrounding the conductors. So because of corona, so many losses will be there. How can you the factors affecting the corona? So similar manner, generally corona will appearing over all the world. How can you reduce the corona? By following the distance, right? By following the distance, we can reduce the coronavirus, not a corona loss. Coronavirus, how can you reduce the corona loss? Is nothing but, so maintain the distance at least 2 feet or 3 feet. Similar manner, corona loss is also reduced with the help of distancing the conductors. By varying the distance increases is nothing but corona loss decreases. So I'll clearly explain the whenever I go to the concept. Next, sag and tension. What is meant by sag is nothing but some of the poles, 2 poles are available. In between these 2 poles, the conductor may be straightly connected to these 2 poles, or some in summer season, so it may taking some curvature, not a straight line between 2 poles. It will taking some curvature. So the length between the curvature, so is nothing but sag. The calculation of sag, and because of tension the sag will appear. So tension calculation also there. So under that one, tower footing restraints and also weight of the conductor, stringing sag templates, some problems will be there. So in this unit, mainly string efficiency calculations, so improvement of string efficiency methods, concept of corona, that is nothing but factors affecting the corona, and some problems on corona, and also sag derivation. So problems more important. Go to the fourth unit, power system transient and traveling waves. Transients is nothing but generally whenever some attenuation will be appear, the waves are flowing through the, so it may be reflected or refracted. That means some of the lines may be reflected, some of the lines may be refracted to the line. So under that one, we have to calculate the current, voltage and impedance values. For you go for the theorem, Bluish lattice diagram, important one, and also the different types of conditions, that is open circuit line, short circuit line, T junction. So under that one, open circuit and short circuit is the more important. Fifth unit, cables, underground cables. So already discussed the cables. Where we are utilizing cables is nothing but cities like Mumbai, Calcutta, where the density of people is more and more. At that time, the overhead lines are, so it may be a complex. So and critical to design the overhead line is a critical one. That's why on that situation we go for the cables like that, underground cables. So what are the textbooks we are utilized is nothing but CL Wadhwa, Electrical Power System. So New Age Publications, New Delhi. So most important textbook. So all of you please buy this textbook, CL Wadhwa, Electrical Power System, new edition, 9th edition. And also another standard textbook is D. Kothar and Isaiah Nagarath, Power System Engineering. And your syllabus, most of your syllabus will cover with the textbook is Principles of Power System by V.K. Mehta and Rohit Mehta. So this is also a good textbook. So you follow this for JN2 examination, you follow V.K. Mehta and Rohit Mehta. So that is enough. But we go for the gate and competition exams. We follow Electrical Power System by CL Wadhwa and Kothari Nagarath, right? And also Turen Gonen for distribution system, right? JB Gupta also good. So we just follow VK Mehta and Rohit Mehta for JN2 examinations. Suppose we go for the gate and competition exams, CL Wadhwa, Kothari and JB Gupta, right? So this is the structure of power system. So this is a generating station. So it is a thermal power plant. So we generate the power 11 kV or 13.8 kV. So this may be stepped up to 132 kV or 220 kV or 400 kV or 440 kV by using a step-up transformer nearby the generating station. In generating station, we have to generate the power. Rating is 11 kV or 33 kV or 13.8 kV. That small voltage will be stepped up to a big voltage, that is 132 kV or 220 kV or a 440 kV or also 750 kV also there. Why? Because the transmission line rating will be now constructed 750 kV lines. So now this amount of high voltage must be transmitted to the transmission lines. So from this onwards, so this is nothing step up transformer. So this is nothing but a switchgear station at the generating station. So from this, the transmission system will be started. So this is the primary transmission where the voltage will be stepped down. Suppose 132 kV, we take it as 132 kV. So this 11 kV will be stepped up to 132 kV. That 132 kV is stepped down to 66 kV. So 132 kV to 66 kV is the primary transmission system. Now from this onwards, secondary transmission will be started. 66 kV to 33 kV. So this transformer, step down transformer, step down the voltage 66 kV to 33 kV. So this is the secondary transmission system. So this is nothing but nearer to the our city, nearer to the our city. So from big industries, they will directly taken to the 11 kV. Here distribution will be started 33 kV to 11 kV. That is the primary distribution. 11 kV to, so this is the, from this onwards to this onwards primary distribution. So this onwards to this onwards, so this is the secondary distribution. So 230 volts for single phase, 440 volt for three phase. So 230 volts. So secondary side of the this transformer to our house will be here, and pole will be there. So secondary side transformer to pole. This is the secondary distribution. So from this pole to our house energy meter is called service main. So this is the structure of the power system, generating the low voltage and stepped up to high voltage that must be transmitted to a long distance, and we have to step it down in a regular manner. So 130 to 66, 66 to, so 33 to 11 to 230 volts. That will go to the our consumer houses, consumer premises. So coming to the our Andhra Pradesh power sector. So this is the regulation committee. Generally, Andhra Pradesh power sector having regulation committee that is named as Andhra Pradesh Electricity Regulation Commission, APERC. So any works, any civil works will comes under this regulation only. Now coming to the generation, Andhra Pradesh Power Generation Corporation Limited, AP Genco, and also, so under this company, the total power will be generated in Andhra Pradesh. Now coming to the transmission, Transmission Corporation of Andhra Pradesh Limited, AP Transco. Under this company, total transmission will be done in the AP. Now coming to the distribution, distribution will be depending upon the area. The distribution system will be distributed. Eastern Power Distribution Company Limited, EPDCL. This may comes under districts of Srikakulam, Vizianagaram, Visakhapatnam, Turpu Godavari, Pachim Godavari. These are all districts comes under Eastern Power Distribution Company Limited. Now coming to the Southern Power Company Distribution Company Limited, APSPDCL. So districts comes under, so Nellore district, Kadapa, Kurnool, Chittoor, Anandapuram, Prakasam, Guntur, Krishna. So you may look ahead our energy meter reading for every month. Tariff energy bill will be coming to your house. So look at that bill, APSPDCL. That is nothing but, so from this distribution company we have to purchase the power. That tariff will be, so how many units you have to consume per a particular month, and what is the tariff value. Tariff is nothing but, so already you have studied the EPGS subject, tariff, different types of tariff, definition of tariff, objective of tariff. So tariff is nothing but the rate for which you have to consume the power. మనం కన్జ్యూమ్ చేసుకునే పవర్కి మనం ఇచ్చే రేటే, అంటే మనీనే. 1 కిలోవాట్ అవర్ పవర్కి కన్జ్యూమ్ చేసుకుంటే ఎంత మనీ ఇస్తున్నాం, అదే టారిఫ్. కమింగ్ టు ది Indian national grid scenario. So grid management on regional basis started. Regional, eastern region, western region, southern region, northern region. So you have to divide total state, total country into 5 regions: northern region, western region, southern region, eastern region, northeast region. So every region we have to one grid and all are connected together. Initially state grids are interconnected from regional grid, but now total India will be divided into only 5 regions, namely northern, western, southern and north south. So from these we have to connect it to the total India. Generally in October 1991, so north east region and east region are connected. These two will be connected in 1991. These two are connected in eastern region, northeast. These two are connected in 1991. In March 2003, western and northeast, these three are connected. That is nothing but northeast, east region 1991 connected, and 2003 these three are connected. And 2013, 2006 it may connect to the east grid also. And December 31st, 2013 the southern region is also connected. That is nothing but total regions are connected in by a date of 31st December 2013. So in synchronous mode with a commissioning of 765 kV transmission line, Raichur and Solapur transmission line, thereby achieving one nation, one grid and one frequency. This is the Modi slogan, right? One nation, one grid and one frequency. This is the about description. Now I am going to the I am going to the subject directly because 15 minutes is there. So unit 1. So unit 1 is transmission line parameters. Topics is type of conductors, calculation of resistance, and also skin effect and proximity effect. So this class I discussed only skin effect, proximity effect, and also type of conductors, right? So now what is a conductor? Conductor is nothing but it is a physical medium to carry the electrical current or electrical energy from one place to another place. So what are the properties of conductor generally? So mainly it will contains high electrical conductivity, low resistance. Resistance తక్కువ ఉంటే కరెంట్ అనేది ఎక్కువ పోతుంది. అందుకే some of the interest they asking what is meant by superconductor. So what is superconductor is nothing but a conductor which contains low resistance. That conductor is called superconductor. That is nothing but most of the electrical energy will transfer to that conductor is called superconductor. So a good conductor will having high electrical conductivity, high tensile strength. That is nothing but is there any mechanical stresses coming from the atmosphere? So from that mechanical atmosphere you have to sustain by using this high tensile strength. ఏదైనా గాలులు తుఫాన్లు ఏ వచ్చినా కానీ తట్టుకునే విధంగా కండక్టర్ అనేది మనం మేడప్ చేయాలి. దట్ ఈస్ నథింగ్ బట్ టెన్స్టైల్ స్ట్రెంగ్త్ అండ్ లోయర్ వెయిట్ పర్ యూనిట్ వాల్యూమ్. సో అండ్ ఆల్సో lower cost compared to the remaining properties. What are the conducting materials are there? Copper, mainly copper, aluminum, alloys like silver, galvanized steel, cadmium, phosphor, bronze, etc. So many will be there, but mainly the conductors are classified into solid conductors and also bundle conductors and also some other conductors will available. So under that one, first standard conductors, solid conductors, standard conductors and also bundle conductors. So what is meant by solid conductor? So it consists of two or more smaller cross sectional strands which are twisted together to get the required strength and running in parallel to increase the current carrying capacity. That is nothing but some of the small conductors. So like this, you look at this one, small conductors will be composed together and they meet required tensile strength to carry the power. That is nothing but solid conductors. Now coming to the next, standard conductors. In standard conductors, again classified into homogeneous and composite. Homogeneous is nothing but all are made up of aluminum standards. That is nothing but only one material. Homogeneous conductor is nothing but the conductor is completely made up of one material only. It may be a copper or aluminum, but most of the time they will made up of copper. So the conductor is made up of copper. That conductor is called homogeneous conductor. What is the main advantage of that conductor is nothing but easy to string and reduced skin effect. Skin effect తక్కువగా ఉంటుంది అండ్ ఎక్కడ పడితే అక్కడ మనం యూజ్ చేసుకో అంటే ఉంచుకోవచ్చు అంటే మనకు ఫ్లెక్సిబిలిటీ ఎక్కువగా ఉంటుంది అది మెయిన్. సో ఇన్ ఆర్డర్ టు కాకపోతే వాట్ ఆర్ ది మెయిన్ డిసడ్వాంటేజ్ కాస్ట్ వైజ్ అండ్ ఆల్సో సో టెన్స్టైల్ స్ట్రెంత్ ఈజ్ లో. Tensile strength is low is nothing but that is more effective and cost is also high. So because of these two reasons, to improve the tensile strength and also reduce the cost, so go for the composite conductors. Standard conductors are two types: homogeneous, composite. Homogeneous is nothing but is made up of only one conductor, that is copper. Copper having low tensile strength, high cost. Because of these two disadvantages, we go for the another. Hello, are you hearing me? Hello.
Yes, sir.
మీకు స్లైడ్స్ కనిపిస్తున్నాయా?
కనిపిస్తున్నాయి సార్.
కనిపిస్తున్నాయా?
సార్.
నాకు కనిపించలేదు ఇక్కడ. ఓకే ఓకే ఓకే. సో but coming to the composite conductors, so that is nothing but ACSR conductor, steel reinforced aluminum conductors. Steel reinforced aluminum conductors, otherwise aluminum conductor steel reinforced. So this is the best one, and nowadays we are utilizing this one only. So you observe that ACSR conductor. So this is the diagram for ACSR conductor. In the middle of the conductor, we are utilizing steel conductor, right? So that steel conductor is covered by aluminum conductors. These are all aluminum conductors. That is nothing but steel reinforced aluminum conductors, otherwise aluminum conductor steel reinforced. So these having high tensile strength and also cost will be less compared to that one. That's why you are utilizing this one. So in aluminum, central strands are having the low conductivity, high tensile strength. Because of that's only we are utilizing steel. స్టీల్ అనేది ఎక్కువ వంగదు కాబట్టి అది టెన్సైల్ స్ట్రెంత్ ఎక్కువ ఉంటుంది దాన్ని మనం మిడిల్లో ఉంచుతాం. చుట్టూ మాత్రం అల్యూమినియం స్టాండ్స్. అది less cost. So advantage of the ACSR conductor is less cost, easy stringing, reduced skin effect. So in an aluminum conductor, so many conductors will be there. AAC, all aluminum conductor, complete aluminum conductor ne utilize cheyadam kaana dani valla disadvantages unnai. Some of the disadvantages will available in AAC and AAAC, all aluminum alloy conductors. Some of the material will be added to the AAC aluminum conductor, that is also having some disadvantage. And ACSR, aluminum conductor steel reinforced, this is the best one. So strands aluminum ఎక్కువ ఉంటాయి, స్టీల్ తక్కువ ఉంటాయి. Suppose we have to represent 22/7 ACSR conductor is nothing but అంటే అక్కడ 22 కండక్టర్స్ వచ్చేసి అల్యూమినియం, 7 కండక్టర్స్ మాత్రమే స్టీల్, లేదా 7/27 ఎలా అయినా అనుకోవచ్చు. స్టీల్ రెయిన్ఫోర్స్డ్ అల్యూమినియం కండక్టర్ ఆర్ అల్యూమినియం కండక్టర్ స్టీల్ రెయిన్ఫోర్స్డ్. సో ఎక్కువ అల్యూమినియం ఉంటుంది, సో తక్కువ స్టీల్ ఉంటుంది. సో 22/7 మీన్స్ 22 అల్యూమినియం. సో అదేవిధంగా ఇవి వచ్చేసి స్టీల్ వచ్చేసి 7 ఉంటుంది. అండ్ లాస్ట్ వన్ బండిల్ కండక్టర్. These are most important for competition exams. Bundle conductors are one which consists of two or more subconductors for phase, which are separated by a small spacing s. They are connected in parallel to increase the power carrying capacity. And also by using this one, and that is nothing but this will be more conductor but the distance ఎక్కువ ఉంటుంది. So that's why reducing the corona loss because of by using bundle conductor. To reduce the corona, we are using bundle conductors. So may why because means bundle conductors are is one which consists of two or more subconductors which are separated by a small distance s, and they are connected to parallel to increase the power carrying capacity and also current carrying capacity. Each subconductor again composite to this ACSR conductor. చాలా కండక్టర్లు ఉంటాయి, టూ ఆర్ మోర్ కండక్టర్స్ ఉంటాయి, అవి కూడా కొంత దూరం సపరేట్ అయి ఉంటాయి. మళ్ళీ ఈచ్ సబ్ కండక్టర్ హ్యావింగ్ మళ్ళీ ఏసీఎస్ఆర్ కండక్టర్. Generally these are the type of conductors: solid conductors, standard conductors. In standard conductors again two types: homogeneous, composite, and last one bundle conductors, right? Now go for the transmission line parameters. Generally transmission line contains four parameters already discussed starting: resistance, inductance, capacitance, conductance. So series resistance is very important in transmission efficiency evaluation and economic studies. But coming to the power transmission line, mainly governed by the series inductance only. The capacitance having the charging currents. So how to calculate the resistance is nothing but we know that the basic definition of resistance. Resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section. R proportional to L by A. R is equal to rho L by A, where rho is the specific resistance, ohm per kilometer. L is the length per kilometer. A is the area of cross section in meter square. And R, resistance is nothing but average power loss per phase by I square, ohm per kilometer. So generally transmission line, the power handling capability is high. That is nothing but power capacity is high at higher voltages. So area of cross section is high. ఎప్పుడైతే పవర్ క్యాపబిలిటీ ఎక్కువ అయిందో ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఎక్కువ అయిపోద్ది. హెన్స్ ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఎక్కువ, సో హై మీన్స్ the resistance per kilometer is very very less. So losses are also very very less. So whenever losses are very less in the transmission line, the transmission line efficiency will be improves. That's why the transmission lines are operated higher voltages, not 132 kV, not 220 kV, not 440 and not 750 kV. Nowadays 750 kV transmission lines are available because of higher rating is nothing but losses are low. So generally resistance is independent of distance. So resistance is not depending upon the distance, that is only depending upon the size of the conductor. So and it is also independent on symmetrical and unsymmetrical spacing. So conductor spacing మీద ఆధారపడదు, కండక్టర్ సైజ్ మీద మాత్రం ఆధారపడుతుంది. So it is not depending upon distance also, right? And mainly the resistance will affect three factors: spiraling, temperature and frequency. We know that formula, R is equal to RT into 1 plus alpha T2 minus, so this is the formula for temperature. RT is equal to R naught into 1 plus alpha naught T. Already discussed, this is the familiar formula. So depending upon the values you can determine the easily resistance for the conductors. Now go for the skin effect. This is the most important one. 5 marks or 2 marks. Define 2 marks, define skin effect, otherwise explain skin effect. The tendency of current concentrate on the near the surface of the conductor is called skin effect. That is nothing but you have to look at this picture. So this only the current will be concentrated on the surface of the conductor. Current flows over the surface, not a center of the conductor. At center of the conductor there is no current. So this tendency is called skin effect. So non-uniform distribution of electric current over the surface of this skin of conductor carrying AC is called skin effect. So otherwise we can define in a different manner. The tendency of current concentrate the near the surface of the conductor is called skin effect. So skin effect will arise only AC, not for DC. In DC, the current will concentrate complete conductor. It will uniformly distributed. Suppose we are giving in a conductor, we are giving DC supply, the current will uniformly distributed. Coming to the AC only, the skin effect will arises. Whereas in DC there is no skin effect. AC only, skin effect is nothing but concentrating the current at the near of the surface, not at the center. What are the factors will affect the skin effect is nothing but frequency. Whereas frequency increases, skin effect is also increases. Diameter, it increases with the increase in diameter. Where diameter increases, skin effect is also increases. Shape of the conductor, skin effect is more pronounced in solid conductors and it is a less in standard conductor. That's why you are utilizing standard conductor. Skin effect is more in solid conductor but is less in standard conductor. ACSR conductor is nothing but one type of standard conductor, so skin effect is less. Type of material, skin effect increases with increase in permeability of material. So these are the different parameters affecting the skin effect. Here mainly for our competition exams, this one, frequency increases, skin effect increases, decreases, like that they asking. This is the most important. Frequency increases as well as skin effect is also increases. Now coming to the last one, proximity effect. When the conductors carry the high alternating voltage, the current are non-uniformly distributed on the cross-section area of the conductor. This effect is called proximity effect. That is nothing but, two bundle conductors are there. When conductor carry the high alternating voltage, currents are non-uniform. It is not a uniform. Currents are non-uniform. So that effect is called proximity effect. So suppose if DC flows surface of the conductor, then the current will uniformly distributed around the cross section of the conductor. Hence, in DC there is no proximity effect, only AC only. So factors affecting the proximity effect: frequency, it is also increases with increase in frequency, same as skin effect, and diameter also same as skin effect, it increases. Proximity effect also increases. But structure, this is more pronounced on solid conductor compared to the standard conductor, same as skin effect. And material, so it is also ferromagnetic, that is a magnetic material. So this is the only different from skin and proximity effect. So this is now first class of EPTS introduction. What are the objectives you have to learn from this subject, and what is the syllabus of EPTS, and what are the textbooks, different authors, CL Wadhwa, Kothari, Nagaratan Kothari, and also VK Mehta, JB Gupta, like that. And also type of conductors, and also resistance calculation, skin effect, proximity effect, right? Any question? If you have any question, please ask. You unmute your audio and asking question, please. Please ask any question. EPTS, electrical power transmission system, theory as well as problems.
సార్ ఈ సబ్జెక్ట్ బుక్ బయట దొరికిద్దా సార్? ఈ సబ్జెక్ట్ బుక్ సార్,
సబ్జెక్ట్
బుక్స్ బయట దొరుకుతాయని అడుగుతున్నా సార్.
బయట దొరుకుతాయి. మన ఎందుకు బయట ఎందుకు? All books are available in our library. JB Gupta, VK Mehta, so many textbooks, number of copies are available. So all books are available in our library. You just utilized that opportunity.
తీసుకోవచ్చు సార్ ఇప్పుడు
Yeah. Come to college and take in our books in your ID card.
ఓకే సార్
Any doubt, please ask. So no doubt. So I'm stop recording and presenting.